Welcome viewers, in this video we will see the details about double tuned coupled circuits. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, double tuned coupled circuit. Let us consider this circuit. Two inductors are mutually coupled together. So this is called a coupled circuit. Tuned circuit means bring the circuit into pure resistance by making inductive reactance equal to capacitive reactance, so that both got cancelled, the circuit acts as pure resistance. In this, the double tuned means the capacitor, the tuning is done by the capacitor connected in primary circuit as well as secondary circuit. Single tuned means capacitor connected only in secondary circuit. So double tuned coupled circuit means two inductors are mutually coupled together, that is tuned by the capacitor connected in both primary as well as secondary side. So consider this circuit, two inductors are coupled together. Resistor and inductor value is R1, L1, here R2, L2, dot is available here. Energized, primary coil energized by the AC source EG. The secondary coil we have output voltage E0. The capacitor C1 connected in primary, C2 connected in secondary. Rg is the source resistance. So this is the current direction, I1 in the primary side, I2 in the secondary side. M is the mutual inductance between L1 and L2. In first coil, the current enters in the dotted end, but in second coil, current leaving at the dotted end. So the self-inductance and mutual inductance both are opposite to each other, parallel opposition, because current enters at dotted end in coil 1, current leaves at dotted end in coil 2. So both are opposing. L and M are opposing. It is coming under parallel opposition method. Now for the circuit zone, we consider a special case where the primary and the secondary resonate at the same frequency. Both primary circuit or secondary circuit is resonated at the same frequency, that is omega R. That is equal to 1 divided by L1 C1, that is equal to 1 divided by L2 C2, right? So it's both the circuits resonate at the same frequency. Now we are going to apply the mesh equation, Kirchhoff's voltage law, to frame the equation for both primary coil and secondary coil, right? So what is the mesh equation? The applied voltage E equal to drop across resistor and inductor and capacitor, that is the Kirchhoff's voltage. This is voltage rise equal to voltage drop, right? So in the first circuit we have the voltage source EG equal to the drop across this RG, C1, L1 and R1. All these four elements are available, that is by the current I1, RG plus R1 plus j omega L1 minus j omega C1. These four elements are available, Rg, R1, C1, L1. Then we have mutual inductance available. Mutual inductance due to the secondary coil, so it is multiplied by I2. We already know that both are opposing, parallel opposition, so minus omega M I2. So this is coming under reactance, impedance, resistance, capacitor and inductor. This is coming under mutual inductance M, that is opposing, so negative sign. That mutual inductance in first coil is due to the second coil, so that it is multiplied by I2. Now we will take this equation number 2. This is equation number 1. We will go into the second coil. First we will see the mutual inductance. Mutual inductance in second coil is due to the first coil, so minus j omega M I1, right? That is also opposing, so that negative side, plus I2. Here what are the elements available? R2, L2 and C2. These three elements are available. So R2 plus j omega L2 minus j omega j divided by omega C2 equal to 0. Here there is no source available, so equal to 0. So these two, they take this equation number 3. So this is the equation number, third equation, now equation number 3. So we framed the equation. Now we need to solve this equation in order to identify the I2, current I2, because we need the value of E0, output voltage. Output voltage is nothing but C2 into I2. So that we need the value of I2. So we'll go for the matrix format. The given equation now converted into matrix format. So what is the matrix? V equal to I into R. This is the voltage matrix, current matrix, and the impedance matrix. Right. So the same equation we can write. So this term is nothing but R11. What is R11 or Z11? The impedance available in the first loop 1. This is Z22, this term. Impedance available in the second loop. This is nothing but Z12, this is Z21. That is the impedance available commonly between loop 1 and 2. So this mutual inductance is available between the coil 1 and 2. So minus j omega m, here also minus j omega m. Otherwise we can write the equation as it is. So this is Z11 impedance in the first loop, Z22 impedance in the second loop. This is the Z12, Z21. The current is I1, I2, the voltage is first loop EZ and second loop is 0. Then how to find the I2 value? I2 equal to delta 2 divided by delta. What is the delta? This is delta. Determinant of this matrix is the delta value. Delta 2 is replace the second column with the voltage matrix, that will give delta 2. So first we will find the delta. So this is the delta. We need to multiply these two terms minus these two terms, so that we'll get the value of delta. Now we'll go for the multiplication. So these two terms are multiplied, minus of j omega m into minus of j omega m. Right. Now we'll go for the further simplification. Here j into j become j square. Here minus available, here also minus available, so it will become plus. J square value we know that minus 1. So minus into minus become plus. So this is the delta value. Right, only here we simplify. J minus j into minus j is j square. J square value is minus 1. So it become plus. Now we'll go for the further simplification. Now we'll find the delta 2 value. Delta 2 means second column is replaced by voltage matrix EG and 0. Now we have to cross multiply these two. While cross multiplying, it become 0. Now these two, minus of EJ into minus j omega m. Minus into minus become plus. So that EG j omega m is the delta 2. So that we can easily find the I2 value. I2 equal to delta 2 divided by delta. This is the delta 2 value. This is delta value. Right. So now we got the expression for I2. Now we'll go to the resonance. The case for the resonance. What happen if it is resonance? So this I2 is taken as the equation number 4. At resonance, omega r equal to 1 divided by square root of L1 C1, that is equal to square root of L2 C2. Right. Now at this condition we will find the current I2. Hence at resonant current at the resonant I2 equal to this value. What happened here? In the equation number 4, these two at resonant, these two are equal. So omega j omega L1 equal to j divided by omega C1. So that j omega L1 minus j divided by omega C1, this term become 0 at the resonant. Similarly here also it becomes 0. So j Eg omega m divided by R2 R1, right, this term is 0 plus omega square m square. Only these two terms are available. So this take equation number 5. So we'll take this equation number 5, right? So here this term becomes 0, so that Rg plus R1. This term becomes 0, so only R2 plus omega square m square, right? Now we can go for, now we calculated the resonant current and the resonant condition. Now we'll go for the output voltage E0. E0 equal to I2 into j minus j divided by omega r C2. This is the voltage across the capacitor. Current is I2, the impedance is minus j divided by omega c I2. Now we'll substitute the I2 value. This is I2 value. So omega r dot cancel. Only these two terms cancel. Here minus j available, here j available. So it becomes minus j square EGM divided by the denominator term. Right. Now we'll go for the further simplification. J square value, we know that j square value is minus 1. So it becomes plus. Right. So bring this EG in the denominator. E naught divided by EG. Right. So here we do two things. One is minus j square. J square value is minus 1. So minus into minus become plus. EG is brought to the denominator this side. So this EG divided by E naught divided by EG. Output voltage divided by source voltage is nothing but amplification factor. So that is M divided by C2 of R2 into Rg plus R1 plus omega square M square. Right. Now this is equation number 7. This is nothing but the amplification factor. So we calculated first the current, secondary current I2, then secondary current at the resonance. By using that I2 we calculated the output voltage E0. From that we calculated the amplification factor. Now we'll go for the maximum value. The maximum value of A, that is amplification factor, or maximum value of E0 can be obtained by taking the first derivative of A or E0 with respect to M and equating to 0. Right. So now we are going to find the maximum condition for maximum value of amplification factor and output voltage E0. So that it is mainly depends upon the mutual inductance. In both the cases mutual inductance is dependent. So that dE0 divided by dm is equated to 0. Differentiate with respect to mutual inductance of E0 and equating 0 will get the condition for maximum output voltage. Similarly, differentiate with respect to mutual inductance of A, amplification factor, and equating to 0 will get the condition for maximum amplification. So this is coming under maximum theorem. Maximum theorem means we have to differentiate the term with respect to the particular parameter. Here the parameter is mutual inductance, and equating to 0 will get the condition for maximum value. Similarly, here you can get the condition for maximum amplification and maximum E0. Now we'll go for the derivative. Now we'll derivate this and equate it to 0. So now we'll differentiate the amplification factor with respect to the mutual inductance. dA by dm and equate it to 0. So d by dm of the expression for amplification factor is this m divided by c of R2 in R2 of Rg plus R1 plus omega R square M square, that is equal to 0. Now we need to differentiate with respect to mutual inductance M. M is available in numerator as well as the denominator. So we can use the U by V method. So this term M by C is the U. This remaining term is the V. U and V terms are there. What is the formula? Differentiation of U by V? V du minus U dV divided by V square. So this is the formula. Now first we will substitute the V here. So this term is V into du. U is M by C. So du is 1 by C. Differentiation of dm is 1 minus U. U is M by C into dV. dV is, this term is constant, becomes 0. Omega are also constant. Differentiation of 2m is, m square is 2m. So that is equal to 0 divided by V square. Now we'll go for the further simplification. So here so that is equated to 0. This the term available in the denominator also becomes 0. Only the term available in numerator is available. Right? Here C is there, that is 1 divided by C. R2 of Rg plus R1 plus omega R square M square divided by C minus M by C is there. M divided by C. Here M, here also one M is there. So M square. This 2 is available. Omega R square divided by C. This term is available in the denominator. The total term in the denominator is become 0, only this numerator is available, that is now simplified. The C is available commonly, so we will take the LCM. So R2 of Rg plus R1 plus omega R square M square minus 2 M square omega R square. Right. So this C also now become 0. Only this term is available. Right. So omega R square M square minus 2 omega R square M square. 2 times available. Both are same term. So 1 minus 2 is 1. Right. So omega R square M square minus 2 omega 2 M square omega R square is M square omega R square. That is equal to 0. Now we will go for the further simplification. Bring this term that side, so this negative become positive, right? And bring this term in the denominator. Bring this term, right? What we need is M square, so bring this term in the denominator of that side, so that M square equal to R2 into Rg plus R1 divided by omega R square. This term is brought into the denominator of that side. So M square, so M by taking square root on both the side, it is square root of R2 of Rg plus R1 divided by omega R. Here omega R square is there, omega R. This M become now MC. This MC is nothing but critical value of mutual inductance, right? Because it is differentiated with respect to M and equated to 0. So we'll get the condition for maximum amplification. So at this value, the mutual inductance become critical mutual inductance. The amplification factor become maximum. By substituting this value, we will get the maximum amplification factor. So that this M become MC, critical value of inductance. The maximum value of E0, I2 are obtained by substituting the value of MC in equation E0 and I2. So by substituting this MC, we can get the maximum value of E0 and I2. Now we'll go for the maximum. We'll find the maximum value one by one. So now first we'll find the maximum value of output voltage E0. So this is the expression for E0. In that we are going to substitute M. Here M available the two places. So M is replaced by square root of R2 of Rg plus R1 divided by omega R. So this is the condition we got by using the maximum value theorem. So here also it is substituted. Here square is there, M square. So what happened? This omega R brought to denominator. So Eg of R2 square root of R2 of Rg plus R1 divided by C omega R into R2 of Rg plus R1. Here square is there. So already one omega R square is there. This square root become normal. R2 of Rg plus R1 divided by omega R square. This omega R square got cancelled. Now we'll go for the further simplification. So Eg into this term available divided by C omega R. See this term available 2 times. Both are same. So 2 times of R2 divided by Rg plus R1. Right. So Eg divided by 2 omega C omega R. And this, what about this square root of R2 plus Rg, both are same. Then how will you write this? This equation can be written as, for example, root 3 divided by 3 is there. Let us consider this is the 3. So by multiplying this root 3 divided by this 3 can be written as root 3 into root 3. So this root 3 got cancelled, become 1 by root 3. Right. So as like that it is 1 divided by R2 of square root of R2 of Rg plus R1. Right. So root 3 by 3. This is root 3. This is 3. Right. And that this 3 can be written as root 3 into root 3. Root 3 into root 3 is 3. So this 1 root 3 got cancelled. Now we got 1 divided by root 3. Now we got the value of maximum value of E0, that is equal to Eg divided by 2C into omega R of square root of R2 into Rg plus R1. We'll take this equation number 9. Now we'll go for the maximum value of the current I2, secondary current I2. Maximum value of current. So this is the expression for maximum current I2. In that we are going to substitute here M. Here also M square. Right. Then it is this square is there, this omega r got cancelled. Here we can go for the square. Here square root is there, so it become normal. This omega r square, both are got cancelled. Right. This term available 2 times. This rg of rj plus r1 available 2 times. So here it is written 2 times. So eg divided by 2. The very similar to previous case. Root 3 divided by 3 can be written as 1 by root 3. Right. So based on the same procedure, this is replaced. So I2 equal to Eg divided by 2 of square root of R2 of Rg plus R1. We'll take this equation number 10. This is the expression for maximum value of current I2. So now we got the E0, maximum value of E0 as well as I2. Now we'll go for the further analysis. So from the definition, mutual inductance equal to K into square root of L1 L2. K is the coupling coefficient. The coefficient of coupling K at M equal to MC. The mutual inductance become critical mutual inductance. At that time the K also become critical coefficient of coupling. So that it is given by MC equal to Kc into square root of L1 L2. The critical coupling causes I2 to have the maximum possible value. At resonance, the maximum value of A is obtained by changing the M or by changing the coupling coefficient for the given value of L1 and L2. So during the critical coupling, we are getting maximum value of I2. Similarly, the amplification factor. So the amplification factor, we can change M by MC and also K by Kc. Both are related. So by changing the coupling coefficient also, mutual inductance will changes, right, for a given value of L1 and L2. So in this video, I discussed the double tuned circuit, coupled circuit, the capacitor connected in primary side as well as secondary side. We started the mesh equation. We got the expression for I2. Then we got E0 output voltage. Then we got the maximum value of the I0 and E0 by making dA by dm equal to 0 and dI2 by dm equal to 0. So that we got the expression for critical coefficient of coupling, critical mutual inductance MC. So that is substituted in I0, I2 as well as E0 in order to get the maximum value. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.